In this video, let's take a look at the op-amp circuit with multiple inputs. And the first case, look at very simple inverting configuration. So we have the invert output, so the non-inverting side is in the ground. Our input resistor here. Let's draw this properly. This is go to the inverting, so this wire together go to the inverting side. So we have V1 R1, we have V2 R2, and then the feedback resistor RF here and V out. Okay, now we have V1, V2 are two voltage sources. Okay, the way to analyze this circuit is we can analyze V1 first, then assume so the V2 will be connected to the ground in this case. Okay, when V2 is connected to the ground in the ground potential, and because of the op-amp principle, we know this node here will be the same potential like there, this node, so this will also be 0. And if this is 0, both sides of R2 are connected to 0, there will be no voltage potential, no current flow through R2, so R2 basically is out of the picture. So in this case, we know V01 is minus RF feedback resistor divided by R1 times V1. Okay. By the same token, we can analyze V1 the impacts of V2. Then we can just assume V1 is ground is connected to the ground, and then V1 both sides of V1 have 0 potentials. Then we know V02 is minus RF over R2 and V2. Okay, so the V out, the total V out is a sum of the V01 plus V02 is minus RF R1 V1 minus RF R2 V2. There's a special case if R1 and equal R2 equal RG, and we know the V out equals minus RF over RG V1 minus RF over RG V2. So just replace this R1 R2 equal RG to the equation here, and we get V out equals minus RF RG V1 plus V2. Okay. So that's typical summation for an inverting input op-amp. And if our RF, RG is the same value, so the V out basically equals to the sum of these two inputs. And of course, there's a negative side because there's the inverting side. Remember, this is a transfer function for that. Remember, we are not limited to 2 inputs. You can have multiple inputs. Just keep adding more terms to this equation. Okay, this is very straightforward and simple. Let's look a little bit different case. Say if we have an op-amp in a still have a op-amp in feedback RF RG in the ground. Now look at the case. If the input voltage it's not in the inverting side, if the input is on the non-inverting side, so we have 2 inputs go to the non-inverting side of op-amp. Simply we have V1 and V2. Okay, so R1 R2. Okay, so what's the transfer function for this case? V out. First, let's look at one node. If we look at this node, it should be same voltage potential over the non-inverting, inverting side should be the same voltage potential. That's because of feedback theory. And if we assume this node is VC, okay? If we know the VC of the voltage at this node for the non-inverting operational amplifier, we know that V out in this case equals 1 over RF RG times VC. Okay, so this is still the basic equation we are going to use. Okay, now let's look at the circuitry. Let's look at the impact from V1 first. In this case, we assume V2 is connected to the ground. If V2 is connected to ground, then V1 and we'll go through R1, R2, and form a voltage divider, and the VC, and this case here, VC is equals what? Equals V1 divided by R1 plus R2 times R2. Okay, so the VC just turned into a voltage divider. So, and we could put this equation into the formula, so we know V01, in this case, the contribution from V1 is 1 over RF over RG, and times VC is this one, so it's R2, R1 plus R2 times V1. Okay. Now, if we look the case R1, we look the case how the V2 contributes into the out, contribute to the out, so we can assume V1 is connected to ground. Now V2 will go through resistor R2, and R1 form a voltage divider, and the VC here, in this case, VC equals V2 times divided by R1 plus R2 and times R1. Okay, because the current will flow from V2 or from V2 go through R2, R1, and to the ground. So this node, the voltage and this node turn into these values. And now we can use this transfer functions for standard non-inverting op-amp again. So we have V02 equals 1 plus RF RG times R1 plus R2 times V2. So we now have these two equations. And the V out, the total out, will be V01 plus V02. And this is basically just two equations right here. So we have 1 plus RF RG and R2, R1 plus R2 times V1 plus 1 plus RF RG R1 plus R2 times V2. Here's R1. Okay, it's very long, sounds complicated, very long equations, but for a special case, let's assume R1 equals RF and R2 equals RG. We can take these values, just simplify the equations. Then we know the V out. And turn it to 1 over RF RG times R2's RG RF plus RG V1 plus R1 RF RG plus R1's RF plus RG and V2. In this case, we know RF plus RG basically is here is the same RF plus RG in the numerator, so this can cancel that. RG cancelled. And in this case, RF RG will cancel the bottom side, and then left over is RF over RG. So now this equation is very simple now. V out equals V1 plus RF over RG and V2. Okay, now let's copy this equation to here. For non-inverting input, we have V out equals V1 plus RF, RG, and V2. Let me clean up this equation here. So we have V1 is RF and R2 is RG. So what's the implication with these equations? First, you can compare this equation here, compare this equation and this one. Looks very different, okay? And in this case, the amplification is applied to both the V1, V2. But in this case, for the non-inverting inputs, the output, there will be no amplification for V1, but only have amplification for V2. So this is very useful in a certain case, okay? If this is a V1, basically you can easily use this this topology to add a offset to a signal. For example, if your V2 have a sine wave input like this, if you have a single power supply power rails, and your output will be only limited to the positive cycles. And in this case, what you can do is you can set the V1 to the V1 equals to half the VCC. Okay, then you can shift this whole curve up by to the middle of the power rail. Then you can display the both sides of the both sides of the input, the AC input. So it's very similar circuits, but just because the input are different into the different nodes, the transfer function are very different, and you have very different applications.